Welcome to this lesson of our study of linear algebra, and in this lesson what I'm going to go through is how to show that a system has no unique solution or it doesn't have a unique solution, and if the system is consistent, how to find the general solution. All right, so show that 2x plus 5y, so I have the system here, and I want to show that the system do not have a unique solution. So what I'm going to do is I'm going to write a augmented matrix here, and I want you to pay attention to here. What I'm coming to do, I'm going to separate some values from them. So the augmented matrix for this one is just the values in front of all the variables. You write them in a row of matrix like this, and I'm going to write the end part, these ones, I'm going to write them like that. And for you to know that a system has no solution, have no unique solution, or doesn't have a unique solution, you're going to take this matrix you have here, right? The one that is the coefficient of the variables. Let me put it that way. I think that should help. And maybe call it a matrix A, okay? And that matrix here, I'm going to have 2, 5, 3, 1, 2, 2, 1, 1, 3. And then you're going to show that the determinant of this matrix is actually 0. If you show that the determinant of this matrix is 0, then you can say that the system has no unique solution, or it doesn't have a unique solution. How am I going to find a determinant here? I'm going to show you a trick of finding a determinant of a matrix within just a 3x3 matrix actually. So I have my A to be 2, 5, 3, 1, 2, 2, 1, 1, 3. Now I want to find a determinant of A, right? So the trick is that go to the second row. So this is a trick. Go to the second row, start writing all these values in the second row, but start writing it from the second entry, right? And you go all the way. So you go here, then you come to the 1 here. So what I'm going to do is I'm going to write the second entry is 2. I'm going to write the next one. So I'm going just straight away from 2. Which one do I go to? I go to this guy, which is 2. And I come back to this. So I have 1, 2, 2 in that second row. So what I'm going to do is I'm starting writing from here all the way. Then I come back to that. Okay. So I go to 2. Then from 2, I go to another 2. Then from this 2, I'm going to come to 1. And then I'll end at this same 2 where I started, right? Then you write the next row, which is this. So this is, I'm trying to explain, that is why it's keeping long, okay? So you start from here, you do the same thing, and that's going to be 1, 3, 1, and I end at 1 again because there was a 1. So what I'm doing is I went all the way to that point, right? And that's what I have. Now the next thing to do is I'm left with the first row. So what I'm going to do, I'll write a first row, first element 2 into this guy times that guy minus this guy times that guy, okay? So 2 times 3, I go that way. I get 6 minus 1 times 2, and 6 minus 2 is 4, right? So I have 4, then plus. I write the next value in the first row, 5 into 2 times 1, 2, minus 3 times 1, which is negative 1, right? So 2 minus 3 is negative 1. Then I go to the next one, plus 3, this 3, into 1 times 1, which is 1, minus 2 times 1. So 1 minus 1, my 1 minus 2 is negative 1, right? So I'm going to have 8 minus 5 minus 3, which is 0, right? So this will give me 8 minus 8, that is 0. So once the determinant of that matrix I had it there, this matrix is 0, then it means that, yeah, indeed, your system do not have a unique solution. So that is it. I hope this made sense, right? So if you have a 3x3 matrix and you're trying to find the determinant, this is a quicker way of finding it, okay? Now let's look at the B part that says that if this system is consistent, then we should find a general solution. If it is consistent, it means I'm going to write my original augmented matrix, that is this whole thing again, back, and that I'm going to include these guys, okay? 2, 5, 3 2 1 2 2 4. I have 1 1 3. Is it 10? Right, let me see. Yeah, I have it. So what I'm going to do, I'm going to reduce this, in one way. What you can do is you can try to change row 1 and then should be equal to row 3, or maybe I'm trying to swap them because I know I have 1 here to be a leading one, and that's what I want to do. So this will imply that I have this matrix 1 1 3 1 0, and I didn't do anything to the row 2, but I swapped row 1 and then row 3. So I'm going to write row 1 this way. I'm going to reduce it by multiplying this by 2. I will subtract these two straight away, and then row 1 and row 2 will make sure that this guy is 0, right? And then between row 1 and the row 3, that's when I'm going to multiply. So row 2, a new row 2 that I want should be equal to, or maybe should be given by row 1, original row 1 minus original row 2, right? And then our row 3 should be given by 2 row 1 minus row 3. And so this is going to give us this matrix here: 1 1 3 10 and 0. So row 1 minus 2 is going to be negative 1. 3 minus 2 is going to be 1. 10 minus 4 is going to be 6. And then 2 times that, I'm going to have 0 here. 2 times 1, this is 2, minus 5, that's going to be negative 3. 2 times 3 is 6. Minus 3 is going to be 3. 2 times 10 is 20. Minus 2 is going to be 18, right? Like that. So this is what I have. The next thing to do is to reduce this guy, or the element beneath that or under it. But here there's a negative there. I want to make sure I have a positive one. So I'm going to multiply negative 1 through row 2 to give me a new row 2, and that's going to give us a new matrix: 1 2 3 1 0 0 1 negative 1 negative 6 0 negative 3 3 18. And this is going to reduce to this form. So what I'm going to do is I'm going to multiply row 2 by 3 and add it to row 3. So 2 row 3, or maybe 2 row 2 plus row 3 should give us a new row 3, and that's going to transform to this final matrix, which is 1 2 3 1 0 0 1 negative 1 negative 6 0 0, and a negative 3 times 3, that is sorry, this is supposed to be 3 times row 2. Negative 1 times 3 is negative 3 plus 3, and that is going to give me 0 here. Negative 3 3 times negative 6 is going to be negative 18 plus 18, that's also going to give me 0 here. And remember, the main idea is that if a system has infinitely many solutions, this system actually has infinite, because we know that it has no unique solution. So definitely, since it is consistent and it has solutions, the solution should be infinitely many. One way to do that is that when you have a system that has more unknowns than less equations than the unknowns. Maybe if I have a system that has 2 equations, right? Maybe I have 2x plus y plus z equals something, right? Maybe 1. Maybe I have y minus 3z is equal to maybe 4. I have 2 equations and I have 3 unknowns. That's what I'm looking for. If this happens, then your system has infinitely many solutions, and we can realize that the reduced form of the system, all we've had here, 1 1 3 10, and then this is 0 1 negative 1 negative 6 0 0 0 0, right? What it means is I have x y z here. So in the last row, it conforms that 0x plus 0y plus 0z should give me 0, and that is true because 0 times anything is 0, right? Now the second row here is going to be y minus z is equal to negative 6, and it means that y is equal to z minus 6. And then again, I'm going to have x plus y plus 3z should be equal to 10. And so x is equal to 10 minus 3z minus y. And that's going to be 10 minus 3z minus z minus 6, right? So you're going to have x to be 10 minus 2z plus 6. So that's going to be, minus 4z rather. So that's going to be 10, or maybe 10 plus 6 is 16. So I'm going to have 16 minus 4z. So here, if I choose, I know that x is equal to 16 minus 4z, y is equal to z minus 6, and z is equal to z, right? So if I choose z to be any real number, maybe t, then I can say that my solution x, y, z is actually equal to x is what? 16 minus 4t, right? Because z is actually t. And then my y will be t minus 6, and then my z is going to be t. Right, again, you can split this into the numbers component 16, negative 6, 0, plus t into negative 4, 1, 1. Right, so t multiply these things, you add them, you're going to get the same thing here. So this is the solution to such a problem. Okay, so again, if you have not subscribed to my channel, kindly subscribe. See you in our next video.